What's up, guys? My name is Jeremy. This is my physics extra credit project. Okay, so we got a guy running off a cliff, dropping down, rope swing. Okay, so we think the guy is about 80 kilograms, which is 176 pounds, average size guy, and the size of the rope is 150 feet, and so I converted that into meters, it's about 46 meters. So this is a start to my code. Looks like this. Just a random time, 30 seconds. Just see what it looks like. So we got the arrows representing the parallel and perpendicular forces. And I had a z component, but this graph isn't working. Okay. So, anytime it wants to stop. No. And, alright, there we go. So, wait, fuck you, how do I get out of this? How do I minimize it?
Just click the X.
Hey, I thought this was just leave this on. Don't leave this in there.
No,
Alright, I know you guys got things to do. Okay, so now, the velocity at the bottom, what we did was we set the centripetal force equal to the tension it needed to overcome the gravity. So it's essentially just 2 times mass times gravity. And so the velocity ended up being about 30 meters per second at the bottom. And now it's at about 4 seconds. So 4 seconds. This is not going to be good. Why? This is not. 4 seconds. Alright, right there. So that's at the bottom of the swing. So the force of tension at the bottom is, use the same equation pretty much for the centripetal force equals the tension plus the gravity. And yeah, so the force of tension ended up being about 2,354 newtons to pull up. And okay, there we go. This is so hard to pull in person. Alright, 30 degrees. Okay, so at 30 degrees you have to use the vertical component of the tension, so you gotta do mg times cosine of 30, because we're doing a 30-degree angle. So, let's see, the velocity there ended up being 29.05 meters per second. And the tension, using the same formula again, 2,142 newtons. And, okay, last part, the stretch of the rope. It's essentially just 46 mini springs of 1 meter. And we used, to get the constant K, we looked up online Kern-Mantel rope, which is what we just assumed they're using. And the K ended up being about 3,813. So if you do the formula, the force of tension equals K times the stretch, solving for the stretch, at the bottom, which is not this, I'm not going to show it to you again because it takes forever, it's 0.8 meters. And at this point, the stretch is about 0.56 meters. And yeah, so sorry we had some technical difficulties, but thanks. See ya.